Welcome to this video. In this video we will use superposition to find V0 in the circuit shown below. And the primary purpose of this circuit is to have as many independent sources as you can in a single circuit without getting completely ridiculous, which I think we probably already have. So if you'll remember, the idea behind superposition is that the voltage V0 that I'm interested in is equal to the voltage due to, for example, this current source, which I might call V0 prime, plus the voltage due to this, say, this voltage source, which I might call V0 double prime, plus the voltage due to this voltage source, which I might call V0 triple prime, plus the voltage due to this current source, which I might call V0 quadruple prime, and finally plus the voltage due to this voltage source, which I could call V0 quintuple prime. So the idea is that I will set each of the sources to 0, and then, for example, we'll start by setting all of the sources except this 12 amp source to 0, and then find the voltage due to that 12 amp source, and we'll just repeat that for all the different sources. And once we get to that point, we just add everything up. So let's begin. We'll go to a clean diagram, and again we want V0 prime in this case, which will be the voltage due to this 12 amp source. So the first thing I need to do then is set the other sources to 0. I set a current source to 0 by just completely eliminating it, which I just did. So there's no connection. It's an open circuit. I set these voltage sources to 0 by replacing them with short circuits. So I'll have a short circuit here, a short circuit here, and a short circuit here. Okay, so now all I need to do is find the voltage across this 1 ohm resistor. And I think the way I'll do it is first to find the current going through the 1 ohm resistor, and then the voltage will just be that current times 1 ohm. And I can find the current, let's call this, say, I0, as, or using the current divider, I0 is 12 amps. That's the total current flowing through two parallel resistances. The one it's not flowing through is 2 ohms over 2 ohms plus 4 ohms, where the 4 ohms is the series combination of the 3 ohm and the 1 ohm. So when I work this out, I get I0 is 4 amps, which says then that V0 prime will be minus 1 ohm times 4 amps. The minus sign comes because I've drawn the current I0 as flowing in the opposite direction as I've drawn the polarity V0. So we get then that this is equal to minus 4 volts. Okay, so we've got our first voltage. Let's go back to our original. We now know that V0 prime is negative 4 volts. Wasn't that fun? Okay, let's do the same thing, but now we'll find the output voltage due to this 12 volt source. So if we want to do that, we first need to get rid of all the other sources. I do that by replacing my current sources with short circuit or open circuits, and my voltage sources with short circuits. So we replace these guys and these guys. And I can now look at my circuit. Basically, what's left is a single loop circuit. And with a single loop circuit, I can actually use the voltage divider. We're getting V0 double prime here. V0 double prime is equal to 12 volts times 1 ohm over 3 ohms plus 1 ohm plus 2 ohms, which should be, let's see, 1 ohm over a total of 6 ohms. And I'm multiplying that by 12 volts, so that gives me 2 volts. So that basically says the voltage, the output voltage due to my 12 volt source is 2 volts. So let's go back to our original window and write this down. V0 double prime is 2 volts. Okay. The next thing we need to do is find V0 triple prime, which is the voltage due to this 3 volt source. So we'll bring up a clean copy. And the first thing we'll do is cut out all of the other sources besides our 3 volt source. And we will replace our voltage sources by short circuits. And we will leave our current sources as open circuits. So now you can see that we have a single loop circuit. I can go around the loop this direction if you want. And if I do that, then I can say that, and this will be V0 triple prime, we have V0 triple prime is minus 3 volts, and the negative sign comes because the sign of the orientation of my 3 volt source is opposite to the way I've defined V out triple prime. So I have minus 3 volts times 1 ohm over, let's see, 1 ohm plus 3 ohms plus 2 ohms, which gives me then minus 1/2 volt. Okay, so this is the output due to the 3 volt source. Let's go write this down. So we have V0 triple prime is negative 1/2 volt. Okay, so the next thing we'll do then is find the output due to the 2 amp source. So again, I'll bring up a clean copy. And now we're going to go for V0 quadruple prime. The first thing I do is get rid of all my other sources. And replace the voltage sources by short circuits. And the current sources by open circuits. So let's see. I guess the easiest way to solve this is to notice that V0 quadruple prime is the voltage from here to here, which basically the easiest way to solve for this then is to notice that this 1 ohm resistor is in parallel with the series combination of the 2 ohm and the 3 ohm resistor. So we can actually even redraw this to show you how this would work. So I've got my 2 amp source, and now I have the 2 ohm and the 3 ohm in series, which gives me 5 ohms. And that's in parallel with the 1 ohm resistor. And again, this is where our V0 quadruple prime is. Now I can replace the 5 ohm and 1 ohm resistor by their parallel combination, which is going to be 5/6 of an ohm. I get that by 1 ohm times 5 ohms over 1 ohm plus 5 ohms. This gives me 5/6 ohms. And I have a current of 2 amps flowing through my 5/6 ohms. So this says that V0 quadruple prime is going to be 5/3 volts. Okay, well, let's go write this down. V0 quadruple prime is 5/3 volts. And finally, I need to find V0 quintuple prime. That's the voltage due to the 6-volt source. So I'll bring up one last clean copy here. And we're looking for V0 quintuple prime. We'll get rid of all the other sources. And replace the voltage sources by short circuits. And leave the current sources as open circuits. And now you can see I have a single loop circuit. I have 6 volts across a total of 6 ohms. So I can just use a voltage divider here. 6 volts times 1 ohm over 1 ohm plus 2 ohms plus 3 ohms, which is equal to 1 volt. So then I can go back to my original, and I have V0 quintuple prime is equal to 1 volt. So now I can sum these guys all up. So we have V0 will be minus 4 volts plus 2 volts minus 1/2 volt plus 5/3 volts plus 1 volt. And so let's see, if I add these all up, and I can do it correctly, which is a big if. Let's see, -4 plus 2 is -2, -2.5, -1.5. So if I've done this correctly, this ends up being 1/6 volt. So there you have it. We've used superposition to find V0 in response to 5 different sources. Again, this is an example that's fairly extreme. You don't see this sort of stuff occur much in real life, but it is a smashing example of how to use superposition to solve a circuit. So with that, we'll be done with this video. Thanks for watching.